Hello. So we're going to look now at a little bit more advanced pH calculations now that we've gotten the basics down. Before we get into that, we have to cover one topic that will help put everything in perspective, and that's called the autoionization of water. So the autoionization of water is just the fact that water is a really special substance that can act like an acid or a base. And so what that means is that water can actually react with itself to form hydronium ions and hydroxide ions. So this happens in pure water. It just happens to a really small amount. So we have very tiny amounts of those present in any amount of water. This reaction is called the autoionization of water. And it's been studied, and we find this mathematical expression that says there's a certain constant, this capital K with the W means that it's the autoionization of water. This constant is always equal to the hydronium ion concentration times the hydroxide ion concentration. So this value, the autoionization of water, is equivalent to 1 times 10 to the minus 14th. So at 25 degrees centigrade, 1 times 10 to the minus 14th always equals the hydronium ion concentration times the hydroxide concentration. That will always be true. Just a couple points here. This is an exact number, so there's an infinite number of sig figs. We don't have to worry about that limiting the calculation. So again, to rewrite this a different way, 1 times 10 to the minus 14th always equals the hydronium ion concentration times the hydroxide ion concentration. Now, as a reminder, we've already learned that the pH of any solution is equal to the negative log of the hydronium ion concentration. And simultaneously, we learned we can do the reverse calculation. We can calculate the concentration if we take 10 raised to the negative pH. Now, we can do exactly the same thing with hydroxide, except we're not calculating pH, we're calculating something called pOH. The pOH of a solution will be equal to the negative log of the concentration of the OH, and the concentration of the OH is equal to P10 raised to the negative pOH. This isn't something that we do very often with our solutions, but it is useful, because another thing that we can say here is that the pOH plus the pH of any solution always equals 14. So this is another important equation. And then again, this is coming from our autoionization of water. So when we're calculating pH in more advanced problems, these are the key concepts, the key equations that we need to know. The key equations. And this will allow us to do slightly more complicated pH calculations than what we first covered. So here's our first question that I want to work on with our new, more advanced equations. If the pH of a solution is 9.7, calculate the hydroxide ion concentration. Now, since we've learned these new equations, there's multiple ways to approach this. And so there isn't exactly one right way to do it. You could do it a couple different ways. The first way that I'm going to work this problem is by calculating what the pOH is. So I'm going to say the pH plus the pOH equals 14. So then if I plug in my pH, 9.7, plus the pOH equal to 14, I can solve for the fact that the pOH equals 4.3. I got that by subtracting 9.7 from both sides. Now that I know the pOH value, I can find the OH concentration by using the fact that the OH concentration is equal to 10 raised to the minus pOH. So again, that comes from that pOH equation. So my concentration of OH minus will be equal to 10 raised to the minus 4.3. So my OH minus concentration will be equal to 4.3 negative second log. 5.01 times 10 to the minus fifth. Let's just double check that. Yeah, 5.01 times 10 to the negative fifth. The other way we could have done this problem was to take this pH value, pH equals 9.7, and figure out the hydronium ion concentration. So what I can do is I can say the hydronium ion concentration is equal to 10 raised to the minus 9.7. This will give me the hydronium ion concentration. So I'm going to take 9.7 negative second log. And so we get the hydronium ion concentration equal to it's going to be 2.00 times 10 to the negative 10th. That will be the hydronium ion concentration. Now we can use the Kw, the autoionization equation. 1 times 10 to the minus 14th equals concentration of acid times concentration of base. Plug in my concentration of acid, 1 times 10 to the minus 14th equals 2.00 times 10 to the minus 10th times my hydroxide ion concentration. And I can solve for my hydroxide ion concentration by dividing both sides by 2.00 times 10 to the minus 10th. So I'm going to start with 1 times 10 to the 14th, negative 14th, divided by 2 times 10 to the negative 10th. And we get 5 times 10 to the negative 5th. 5 times 10 to the negative 5th. And you can see here that we got the same answer either way that we worked it. One way is not better than the other way, it's just whichever way makes most sense to you. Okay, looking at a second problem, if the OH concentration is 7.3 times 10 to the minus 9th, sorry, this should indicate that it's in molarity, calculate the pH. So again, multiple ways to approach this. I'm going to just keep in mind that I can calculate the pOH by taking the negative log of 7.3 times 10 to the minus 9th. So the pOH, I'm taking the OH concentration and I'm doing the log of that. So here we have pOH equal to 7.3 times 10 minus and that minus cancel, so I'm left with the pOH of 8.14. Now this is the pOH. To get the pH, I have to keep in mind that the pH plus the pOH always equal 14. So if I plug in the pH equals 8 plus 8.14 equals 14, and get the pH equal to 5.86 when we do that math. The final question just shows that we can really, given one thing, the hydronium ion concentration, we can calculate all three of the other species that are present in solution. So we're going to go through this problem where we calculate everything given one of the things. And this is true for any one of these things. If I was given the pOH, I could calculate the other three. If I was given the pH, I could calculate the other three. So given any one of these four values, we can calculate the other three. So since I've been given the hydronium ion concentration, I'm going to just start with what's easy here. I'm going to start with calculating the pH. The pH of the solution will equal the negative log of 2.5 times 10 to the minus 4. That will give me the pOH concentration. 2.5 times 10 to the negative 4th. Take the log of that, and then we'll make it positive. That negative and that negative cancel. So the pH equals 3.60. Now to get the pOH plus 3.60 equals 14. So the pOH equals 10.40. So we've got the pH, and now we have the pOH. Now to get the hydroxide ion concentration, I'm going to use the pOH value. I'm going to say concentration of hydroxide equals 10 raised to the negative 10.40 to the negative pOH. So I will take 10.4, make that negative, and take the second log. And we get the hydroxide ion concentration equal to 3.98 times 10 to the minus 11. That's an 11. So you can see now we've got the hydroxide ion concentration. So we calculated 3 values just given the one that they gave us in this question. So those are all related. And like I said, there's multiple ways to do these problems. I like to refer to this here is a sort of a little chart that shows how they're all connected. I like to call this the square of fun, but it's pH fun. Aha, square of pH fun. But you can see here, we first learned just the simple pH calculation. Given the hydronium ion concentration, we can take the negative log and get the pH. Given the pH, we take 10 raised to the negative value, and we get the hydronium ion concentration. The exact same thing is true for the OH concentration and the pOH. Negative log of the OH concentration gives us pOH. 10 to the negative, sorry, this should be pOH. 10 to the negative pOH. Let's just rewrite this whole thing. 10 to the negative pOH gives us the OH concentration. Now these two parts of this are connected though by the autoionization of water. So the autoionization of water says that these two things are connected through this constant. 1 times 10 to the minus 14 equals hydronium ion concentration times hydroxide concentration. So given one of these, I can calculate the other one. But this also relates the pH to the pOH. pH plus pOH equals 14. So you can see this makes a connection between all 4 of these values. Given any one of the values, we can calculate any of the other ones. Okay, that's it for the second installment of the more advanced pH calculations.